Hi friends, welcome to Think Max. This is class 10 Max. Today we are going to discuss about theorem 1.5, 1.6 and 1.7. So theorem 1.5, let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form p by q, where p and q are co-prime and the prime factorization of q is of the form 2 power n into 5 power m, where n and m are non-negative integers. So here they gave a rational number, the decimal expansion terminates. Okay. Now we have to prove that the x can be expressed in the form p by q, where p and q are co-prime. So co-prime are, they have factors, but only the common factor will be 1. So and their prime factorization should be 2 power n into 5 power n. This n and m are non-negative, that is 0, 1, 2, etc. Positive plus 0. Okay, so we will prove this theorem using numbers. Suppose x, which is equal to p by q, that is x is a rational number. I take the rational number as 73 by 100. Okay, so first let us check whether this rational number is of the form terminating. Okay, so first let me divide 73 by 100. So this 73 is not divisible by 100. So I add one 0 here and I put a point here. So 730. This goes 7 times 7 into 100 is 700. Remaining will be 30. So I can add one 0. So it goes 3 times. So 300. So the answer is 0.73 as it ends with 0. So the remainder is 0. So the answer is 0.73. That is, it has a decimal expansion which terminates. Then we have to prove that x can be expressed in the form 2 power n into 5 power m. Okay, so this q is equal to 100. So we have to factorize 100. Let me take the prime number 2. 5 2s are 10, remaining 0. Again 2. 2 2s are 4, balance 1. 5 2s are 10 and 5 5s are 25. So 5 1s are 5. So 100 can be expressed as 2 into 5 into 5. So this is nothing but 2 power 2 into 5 power 2. So when x is a rational number and its decimal expansion terminates, we can write the denominator q as of the form 2 power n into 5 power n. Here we have showed that this decimal expansion 100 can be written as 2 power 2 into 5 power 2. Okay, so this is the proof of the theorem. So we are proving using the numbers. Okay, so let me go to the next theorem. So theorem 1.6. So let x is equal to p by q be a rational number such that the prime factorization of q is of the form 2 power n into 5 power m, where n, m are non-negative integers. Then x has a decimal expansion which terminates. Here they gave q is of the form 2 power n into 5 power m. Okay, so then we have to show that the decimal expansion of x is of the x terminates. Okay children, so let me take one example. X is equal to p by q. Suppose I take 14 divided by 2 power 2 into 5 power 1. So they gave q is of the form 2 power n into 5 power m. So I can take 2 power 2 into 5 power 1. So 14 divided by 2 power 2 is 4. So 4 into 5, 20. So let us divide and check. 14. So 14 is not divisible by 20. So I add one 0 here and I put a point in the quotient. So how many times it goes? It goes 7 times. So 7 into 20 is 140 and the remainder is 0. So the answer is 0.7. So the decimal expansion is terminate. Okay. So suppose I take another example, 13. 13 by 2 power 2 into 5 power 1. The same way let us divide 13 divided by, so 2 power 2 into 5 power 1 is 20. So let us check the answer. So 13 is not divisible by 20. So I add one 0 here. So here one point will be added here. So what happens? How many times it goes? 6 times shall we take? So if I take 6 times, this 6 into 20 is 120. So 0, 3 minus 2 will be 1. So again I add one 0. So 5 times. So 5 into 20 is 100. So the remainder is 0. So the answer is 0.65. So it is terminating. Okay. So some more examples can be taken. Suppose I take the value x is equal to 15 divided by 2 power 0. So anything power 0 is 1. So n can take the value 0 also. So 2 power 0 into 5 power 2. So which is equal to 15 divided by 2 power 0 is 1. 5 square is 25. So 1 into 25 is 25. So 15 divided by 25. So suppose I take 15. If I divide by 25. So 15 is not divisible by 25. So I add one 0. So and a point in the quotient. So how many times it goes? I think it goes 6 times. So 6 5s are 30, balance 3, 2 6 are 12, 12 plus 3, 15. So 150. So I get the remainder as 0. So which is equal to 0.6. So it terminates. So in the same way we can take 15 divided by 2 power 2 into 5 power 0. So 15 divided by 2 power 2 is 4, 5 power 0 is 1. So 2 power 2, 4. So 15 divided by 4. So if I divide by 4, so 3 4s are 12. So balance will be 3. So 3 is not divisible by 4. So I add one 0 and a point here. So 7 4s are 28. Balance is 2. So I add one 0. 5 4s are 20. So the remainder is 0. So the answer is 3.75. So we have proved with all types of example that if x is equal to p by q is a rational number such that the prime factorization of q is of the form 2 power n into 5 power m, where n and m are in negative integers, then x has a decimal expansion which terminates. Okay friends, so let me go to the next theorem. Theorem 1.7, that x is equal to p by q be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m, where n comma m are non-negative integers. Then x has a decimal expansion which is non-terminating repeating. Okay. So they gave the rational number x is equal to rational number and p is not of the form 2 power n into 5 power n. Then we have to show that x has a decimal expansion which is non-terminating. So it does not end. Okay. So terminating means ends. Here they give non-terminating, so it does not ends and repeats. Okay. So let me take one example. X is equal to p by q. So p by q is of the form 1 by 3. Okay. So let me divide 1 by 3. So 1 is not divisible by 3. So adding 1 0. So I add a point in the quotient. So 3 3s are 9. So 10 minus 9 is 1. Adding 1 0. 3 3s are 9. Again 1. Adding 1 0. 3 3s are 9. So this will be repeated without n. So we can write as 0.3 bar. This bar means this 3 will be repeated without n. That is non-terminating repeating, because we took as 1 by 3. This 3 cannot be expressed as 2 power n into 5 power n. So if this not expressed as 2 power n into 5 power n, that is denominator in the rational number cannot be expressed as 2 power n into 5 power n, then its answer will be in the form non-terminating and repeating. That is, their decimal expansion will be of the form non-terminating repeating. Suppose I take another example, 3 by 11. So 3 cannot be divided. So I add 1 0, 0 point. So 2 into 11 will be 22. So 30 minus 22 is 8. Adding 1 0. 7 into 11, 77. So 80 minus 77 is 3. Adding 1 0. So 2 into 11 will be 22. Again 8 will be remainder. So again 80, that is 7. Again this 22. So this, no, 77. Remainder will be 3. So this will go without n. So the decimal expansion of 3 by 11 will be 0.27 bar. That is, this 27 will be repeated without n. So the decimal expansion is non-terminating repeating, because the denominator q is not of the form 2 power n into 5 power n. So if this is not of the form 2 power n into 5 power n, their decimal expansion will be non-terminating repeat. Okay. Okay friends, I hope you can understand. So this is for this session. Thank you for watching. So we will meet in the next video. So if you enjoy this video, just like, share and subscribe and hit the bell button so that you get the notification whenever I upload my videos. Thank you for your support.